Hello everyone. Today we will discuss about MPU6050 Sensor Module. So what is MPU6050? So it is a 6-axis motion tracking device. It combines 3-axis gyroscope, 3-axis accelerometer and also digital motion processor all in a small package. And also it has additional feature that is on chip temperature sensor, and it has I2C bus interface to communicate with the microcontroller. So in this sensor module there are total 8 pins. So this is the total 8 pins. The first pin is the VCC that we will connect to the power supply. We will connect this pin to plus 3 volt to plus 5 volt DC supply. The next pin is the ground pin that we connect to the ground connection, and the next pin is the SCL and SDA. These are the I2C pin, and the SCL means serial clock pin and this is the serial data. We need to connect this pin to the SCL and SDA pin respectively to the microcontroller. The next two pins are auxiliary serial clock, XDA and XCL. These are the auxiliary serial clock and serial data pin. This pin we use to connect other I2C interface enabled sensor to MPU6050. The next is the AD0 pin, that is the I2C slave address LSB pin. So by default this pin is connected to ground. So when we want to interface another MPU6050 to the microcontroller, in this case we will connect another AD0 to the high. So means we can connect two sensor to a single microcontroller. The next is the interrupt digital output pin. So in this experiment, when we will use this MPU6050 sensor module, we will use only 4 pin, that is the VCC, ground, SCL and SDA. Now in this module there is a accelerometer and gyroscope. So what is accelerometer? How accelerometer works? So to know how accelerometer works, it is often useful to imagine a ball inside a 3D cube. So accelerometer actually measures the static acceleration of gravity in tilt sensing application, and as well as it will measure dynamic acceleration resulting from motion, shock or vibration. So we want to know how accelerometer works. So suppose the cube is in a outer space where everything is in weightless state. So the ball will simply float in the middle of the cube. So this is the cube. Inside this cube is in a weightless state, and you have to imagine there is a 3D ball, and this 3D ball will simply float in the middle of the cube. So now let's imagine each ball represent particular axis. So this is the x plus, x minus, y plus, y minus, and our side z plus, z minus. So if we suddenly move the box to the left side with the acceleration 1g, that is equal to 9.8 meter per second square, so no doubt the ball will hit the wall x. See here. So if we measure the force that the ball applied to the wall x, so we can get output value of 1g on the x-axis, like we are getting 1g value. And let's see what happens if we put the cube on earth. The ball will simply fall onto the wall on the z-axis, so and will apply a force of 1g, that's shown in the pictures. So in this case the box is not moving in the third case, but we still get a reading of 1g on the z-axis. This is because of the gravitational force is pulling the ball with force 1g. So now the accelerometer, this is the, in this mechanism we can calculate the acceleration, but in the small ICs. So there is a technology, how can we apply this thing in small ICs? So for this there is a new technology that is called MEMS, micro electromechanical system. So there is a MEMS accelerometer consists of micro machine structure built on top of a silicon wafer. So in this structure, these are the polysilicon springs are there. These are the polysilicon springs, and these are the fixed plates. These are the 8 fixed plates, and it's complete structure on silicon wafer, and there are the some you can say the suspended mass is moving. So see here, so this structure is suspended by polysilicon spring. So it allows the structure to deflect at the time when acceleration is applied on a particular axis. So due to the deflection, the capacitance between the fixed plate will change and the plate attached to the suspended structure is changed. So see here, the capacitance is changing. So we are, by moving these plates, the capacitance between plates are changing. So this change in capacitance is proportional to the acceleration on that axis. Okay, so the sensor process this change in capacitance and convert it into an analog output voltage. Okay, so due to this technology, we are able to get the complete acceleration in X, Y, Z direction. So in every direction we put a MEMS structure that measuring the acceleration. So this is the, by MEMS technology we are measuring the acceleration. Now how gyroscope work? So while accelerometer measure linear acceleration, MEMS gyroscope measure angular rotation. So to do this, they measure the force generated by what is known the Coriolis effect. So what is Coriolis effect? So Coriolis effect tell us that when a mass m moves in a particular direction with velocity v, we can say the particular direction is the x direction, this mass is moving with velocity v, and the external angular rate, that is the angular rate omega, is applied, that is shown in red arrow. So due to the Coriolis effect, it generates a force in the direction of this yellow arrow that causes a perpendicular displacement of the mass. So the value of this displacement is directly related to the angular rate applied. Okay, so now suppose there are two masses that kept in a constant oscillation motion, so that they move continuously in opposite directions. So when angular rate is applied, due to the Coriolis effect on each mass is also in opposite direction, so which result in change in the capacitance between them. So this change is capacitance by which we can calculate the voltage, then we can get the accelerometer reading, or we can get the gyroscope reading. So now same the MEMS technology applied into the 3-axis gyroscope. So the MPU6050 consists 3-axis gyroscope with MEMS technology. It is used to detect rotational velocity along the X, Y and Z direction. So there are 4 plates, M1, M2, M3 and M4. Okay, so when we start rotating the structure, the Coriolis force acting on the moving proof mass changes the direction of the vibration from horizontal to vertical. So there are 3 modes. The first mode is the roll mode. So when angular rate is applied onto the Z axis, so due to the Coriolis effect, that M1, M3 will move up and down of the plane. This causes the roll angle to change. Hence it is called the roll mode. See here, these plates are oscillating like up and down. Similarly, the next is the pitch mode. So when angular rate is applied along the y axis, then there are deflection in M2 and M4 will move up and down. So this causes the pitch angle to change. Hence it is called pitch mode. And the next is the yaw mode, when angular rate is applied along the Z axis. So M2, M4 will move in the same horizontal plane in opposite direction. This causes the yaw angle to change. Hence it is called the yaw mode. So when the Coriolis effect is detected, This continuous movement of the driving mass will cause a capacitance change, which is picked up by the sensing structure, then converted to a voltage. So this is the MEMS structure die in 3-axis gyroscope. This is the we can say that this is the structure by Adam McCombs, the inside in gyroscope. Okay. So now we will talk about MPU6050 module hardware overview. So at the heart of the module there is a low power inexpensive 6-axis motion tracking chip that combine a 3-axis gyroscope, 3-axis accelerometer and a digital motion processor in a small 4mm into 4mm package. It can measure angular momentum or rotation along the 3-axis due to the static acceleration or dynamic acceleration. So this is the in middle, there is a IC, there are voltage regulator and there is a power on LED. The module come with onboard LD3985 3.3 volt regulator. So you can use it with 5 volt logic microcontroller like Arduino without worry. So MPU6050 consume less than 3.6 milliampere during measurement and only 5 microampere during idle. So this low power consumption allow the implementation in battery driven applications also. And how to measure acceleration? The MPU6050 can measure acceleration using its own chip accelerometer with 4 programmable full scale ranges like plus minus 2G, plus minus 4G, plus minus 8G and plus minus 16G. The MPU6050 has 3 16-bit analog to digital converter that simultaneously sample the 3 axes of the movement in X, Y and Z directions. Similarly, MPU6050 can measure angular rotation using its own chip gyroscope with 4 programmable full scale 250 degree per second, 5 plus minus 500 degree per second, plus minus 1000 degree per second and plus minus 2000 degree per second. Similarly, there is also 3 analog to digital 16-bit ADCs are there, and the sampling rate can be adjusted from 3.9 to 8000 sample per second. Calculation, for calculation, imagine you are selecting plus minus 2G, so there is a sensitive scale factor is 16,384. This value you will get from the data sheet. Similarly, if gyroscope range is plus minus 250 degrees centigrade, which sensitivity scale is that is 131 LSB. So you have to divide these value. When you get the raw data, you have to x-axis raw data you have to divide by this, then you will get the value in G. Similarly, you have to divide 131 for the raw data in every axis. So this is our device. We are interfacing. This is our ESP32 LoRa gateway. We are interfacing MPU6050 with this ESP32 LoRa gateway. This is MPU6050 module in out, and this is the connection. As I told you earlier, we are using only 4 pins. The VCC pin is connected to this 3.3 volt. The ground pin is connected to ground, and SCL is connected to SCL. And these are the I2C pin. SDA is connected to SDA. So if you want to use this sensor, you need to install a library. That library is in Arduino IDE. Go to Sketch, include library, then click on Manage Library. So here is the Adafruit MPU6050. You have to install this library. So in this project, we will build a web server with the ESP32 to display reading from the MPU6050 accelerometer and gyroscope sensor. We will also create a 3D representation of the sensor orientation on the web browser. So see here, right now I am moving and we are getting accelerometer and gyroscope readings are there. See here the accelerometer readings in X direction, in Y direction, in Z direction, and accelerometer, see here, if we put in steady state, we are getting the 9.8 meter per second square reading, and whenever we are moving, we are actually in the gyroscope, we are getting the reading in radian per degree centigrade. So see here, the 3D cube is moving according to our, see when I am rotating this, it is also rotating and moving. So see, this is up and down, left, right, moving, and also we are rotating the device on a fixed angle. And we are also getting the temperature also. And we can also reset the position of the sensor like this. Then we can move. So the 3D cube is also moving according to the orientation.